For this video, we're going to begin Activity 13. This is about Lesson 13-1, Angle Relationships in Triangles. Learning goals are to prove some theorems about the angle measures in triangles and to use these theorems about the angle measures. The architectural design of the Rock and Roll Hall of Fame in Cleveland, Ohio includes some triangles, and here's a picture of what that building looks like. Some of the glass panels on the facade need to be replaced. To cut the glass correctly, angle measures of some of the triangles will need to be determined. Jason owns a glass company, and he'll be cutting the glass for the repairs. One of the tools he will use to determine angle measures of the triangles is the parallel postulate. Jason cannot remember the sum of the measures of the angles of a triangle. He begins by drawing one of the triangles of glass he needs to replace. So question 1, this is asking us to draw or trace the triangle below. Let's not take the time to do that and just use this triangle as is. Number 2 says, if we had drawn this on paper and then cut it out with scissors, we could then tear the 3 corners off the triangle. And then it says in number 3, arrange the corners so that they're adjacent. So what that's saying is take the piece of paper that was angle 1, right? You had this little teared off thing here. Right next to it, put the piece of paper that's angle 2 that you had torn off. And then next to that, put the piece of paper that is angle 3 torn off. What's going to happen is that the 3 angles together are going to create a perfectly straight edge. So in number 3, what is formed? A straight angle or a straight line. So the 3 angles of a triangle, when put adjacent to each other, create a straight angle. Number 4, so what appears to be true about the sum of the measures of those angles? Write a conjecture. The sum of the measures of the angles of a triangle is 180 degrees. This is called the triangle sum theorem. We'd actually used this in a previous lesson as a step in one of the proofs. Now this question itself doesn't make a lot of sense, right? It says Jason owns the glass company. He cannot remember that the sum of the angles of a triangle adds up to 180. Man, who'd want to do business with that guy? He can't even remember that simple fact. Okay, but here is one of the theorems about triangles, that the sum of the 3 angles of any triangle is 180 degrees. Okay, number 5, let's work on proving this. When you're given a figure for a proof, you cannot change anything about the figure, but you can add lines to the figure to help you complete a proof. A line used in this manner is called an auxiliary line. The proof of the triangle sum theorem begins by drawing auxiliary line D that intersects point A and is parallel to the bottom of the triangle segment BC. So here in purple, I have drawn an auxiliary line making it parallel to BC. Why are you allowed to draw such a line? And this is where the parallel postulate comes into play. Now, I don't remember this from any previous lessons this year. The parallel postulate is a foundational idea in geometry that says through any point, it is possible to draw one line that's parallel to some other line. We assume that that's true. And that's what a postulate is. Again, remember, a postulate is an assumption that something's true. Okay, number 6, let's make this proof that the 3 angles of a triangle do add up to 180 degrees. So given a triangle called ABC, let's prove that angle 2 plus the measure of angle 1 plus the measure of angle 3 does add up to 180. So first step, through point A, draw that auxiliary line. We're allowed to do that because of the parallel postulate. Next step, let's write down that the measure of angle 5, that's this angle, plus the measure of angle 1, plus the measure of angle 4, is 180 degrees. And we can do that because that's angle addition. That was one of our very first lessons this year, that angles that are side by side can be added together to create the total angle, in this case 180. Okay, next step. We can say that angle 5 is congruent to angle 2, and that angle 4 is congruent to angle 3. We're saying that angle 5 is congruent to angle 2. These are alternate interior angles within these parallel lines. Do you remember that topic from several lessons ago? We have parallel lines, and we have these alternate interior angles, they will be congruent. For the same reason, we can say that angle 4 is congruent to angle 3. 4 and 3 are alternate interior angles between the purple line and then that bottom line there. Okay, step 4. Because we just said we had some angles congruent, we can now say that their measures are equal. Their measures are equal. We've used this reason before in other proofs. That's the definition of congruent angles. When angles are congruent, then their measures are equal. Final step. We can write that the measure of angle 2 plus the measure of angle 1 plus the measure of angle 3 is 180 degrees. That's what we were trying to prove. But where does this come from? We go back to the equation we created in step 2, and where it talks about angle 5, substitutes something that we know is equal to angle 5. That's angle 2. And so this measure of angle 2 here is simply being substituted in this position. Right here where it says the measure of angle 4, substitutes something we know is equal to angle 4, which is from this piece here. Angle 4 is equal to angle 3. So we're taking that and putting it right there. And then we just rewrite that same equation, and it now looks like this. That's the substitution property when you make those replacements. So here we have proved the triangle sum theorem about the three angles of a triangle. Here are some check your understanding questions. I'll pause the video. Next, an interior angle of a triangle is formed by two sides of the triangle. An exterior angle of a triangle is formed by one side of the triangle and the extension of an adjacent side. A remote interior angle of a triangle is an interior angle that is not adjacent to a given exterior angle. So we have these vocabulary words. Sometimes Jason will only know the measure of the exterior angle of a triangle in the facade. He needs to be able to determine the interior angles of a triangle if he knows that exterior angle measure. So number 10, let's make sure we understand what these three vocabulary words are talking about. Label each angle of the triangle using one of the following terms: interior angle, exterior angle, and remote interior angle. So we have a triangle. Its interior angles are 1, 2, and 3. And then by extending the bottom side this direction, another angle, number 4, is labeled. That's the exterior angle. Please understand that we could extend other sides of the triangle and create other exterior angles. We could have extended this direction and created an exterior angle here that's adjacent angle 2. But in this particular drawing, the only exterior angle shown is angle 4. The angle that's adjacent to 4 and inside the triangle, we're going to label that as an interior angle. Now, angle 1 and 2 are also interior of the triangle, but these are remote interior angles because they're not next to angle 4. Number 11, use a protractor to measure angles 1, that's this one, 2, that's this one, and 4, this one out here. So on the video, I can't really show a protractor easily on the screen, so let me just tell you that the numbers turned out to be 85 degrees, 43 degrees, and 128 degrees. Number 12, what appears to be true about the measure of that exterior angle in relationship to those two? Well, do you notice if you add 85 plus 43, that makes 128? So here's my conjecture. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. This is called the exterior angle theorem. So we've had a theorem about the three interior angles, always adding up to 180 degrees. And now we have a theorem about an exterior angle of a triangle. Okay, number 13, let's prove the exterior angle theorem. We're going to use this drawing of a triangle with one side extension to create exterior angle number 4. Let's prove that that angle is equal to the sum of those two angles. So start by saying we have this triangle, that's given. Then we can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. And our reason for knowing those three add up to 180 is the triangle sum theorem that we proved at the beginning of today's lesson. Okay, next step. The measure of angle 3 plus the measure of angle 4 is 180 degrees. Why do we know that that angle plus that angle sitting side by side and creating that straight line is 180? Our reason is the linear pair theorem. That was something from early in the year. Two adjacent angles that create a straight line together are called a linear pair. Next step, take this equation from step 3 and subtract the measure of angle 3 from both sides to get the measure of angle 4 alone. And it would create this algebra expression. That's the subtraction property. Okay, in the next step, we're going to go back to what we had in step 2 and use that fact right there. That angle 1, angle 2, and angle 3 added up is 180. So we have the measure of angle 4 equals, and then we're going to substitute in place of the 180 that long expression from step 2. And then here's the minus angle 3 here on the end. That's substitution. Final step, take this equation and this last piece where we have the measure of angle 3, subtract the measure of angle 3, which would just cancel out, making 0. Rewrite it like this. This is called simplifying, when you take those two things, subtract them away, and cancel them out. So our reason is simplifying. We have now proved the exterior angle theorem, and so we can use that theorem for the rest of geometry class. Here's an example that would use that theorem. The shaded piece of glass shown below is one of the triangles that Jason needs to replace. Jason knows that in this section of the glass facade, the measure of angle 2 is 3 times the measure of angle 1. What are the measures of all the angles in the piece of glass? By the exterior angle theorem, we know that if we add angle 1 and angle 2 together, it will equal the exterior angle. And so we can start by saying the measure of angle 1 plus the measure of angle 2 is equal to 124 degrees. Jason also knew that in this particular piece of glass, that angle 2 was 3 times the measure of angle 1. So let's make a replacement. The measure of angle 1 plus, and then in place of angle 2, let's put 3 times the measure of angle 1. And that's equal to 124. Combining these together, we have 4 times the measure of angle 1 equals 124. And then divide both sides by 4, and we get that angle 1 is 31 degrees. So Jason now knows that that one's 31 degrees. He knew that angle 2 was 3 times that, which is 93 degrees. And remember how the 3 angles inside a triangle add up to 180? If you already know 2 of the angles, you certainly can get that third angle. What is that missing number that would make it add up to 180? All right, here are some try these questions, and I'll pause the video for you. And here are some check your understanding questions, so let me pause the video one more time. So in this lesson, we proved 2 theorems about triangles. One is called the angle sum theorem, that the 3 angles of a triangle sum to 180 degrees. The other was called the exterior angle theorem, that says that the exterior angle is equal to the sum of the 2 remote angles. We also applied the theorems by solving one of the, solving that problem about measuring the glass that's in the Rock and Roll Hall of Fame building.